Hello and welcome to today's talk, Harness the Power of AI for Faster, Accurate Plans. My name is Carolyn Woods from InEight, and I have the pleasure of introducing Dan Patterson, Chief Design Officer at InEight. Dan joined us through an acquisition in 2018 from Basis. Dan is not our only Dan, so we affectionately call him Dr. Dan. Dan is a globally recognized leader in project analytics and a software entrepreneur. He has more than 20 years of experience building project management software companies, including Pertmaster and Acumen before Basis. Throughout his career, Dan has focused on solution innovation and project management, including advanced scheduling, risk management, and project analytics and AI. Dan is a certified PMP, and he has his PhD, in case you were wondering, in construction management. Dan, I'll turn it over to you.
All right. Well, thank you very much, Carolyn, for that very warm and kind introduction. So depending on where in the world you are dialing in from, good morning, good afternoon. As mentioned, my name is Dan Patterson, and I am very excited to spend the next 45 minutes or so sharing with you my thoughts on, in many ways, what I believe to be the next generation with regards to CPM scheduling. The formal title of the presentation, as you can see on the screen, is Harnessing the Power of AI for Faster, More Accurate Plans. And really what that pertains to, I think, is two primary benefits that we're going to focus on today. Firstly, being able to build CPM schedules for CapEx projects in less time is, I think a very obvious benefit. Typically, it takes days, if not weeks, to compile a schedule that is suitable for forecasting a multi-million-dollar project. So, one of the big benefits of the approaches I'm going to share with you today is around making that making that process faster. I think, though, more importantly, the product as a result of this next generation approach or next generation CPM scheduling approach is that the plan that we end up with is more realistic. It wouldn't be very useful if we were building plans faster, but the ultimate result was a less realistic plan. The net here is actually less time to generate the plan and the resultant schedule being more realistic. And Carolyn, you probably heard me harp on before about my my belief around project management has always been quite simple, and that is that projects don't fail because of poor execution. We perceive them to fail because when we build our forecast, whether it's a cost forecast or a schedule forecast, we put our plan together. That plan is overly optimistic and overly aggressive. It doesn't take into account the unknowns, the potential risks, productivity exposure due to things like weather or inexperienced workforce. And so when we talk about projects overrunning with regards to both cost and time, I actually don't believe they are overrunning. I think we perceive them to overrun because of the forecast we put together in the first place was wrong. Does that make sense?
Yes, that's right on target.
Yep. So we're going to talk about an improvement on an age-long scheduling technique known as CPM scheduling. And I think it's important to note that what I'm going to present today is not in any way trying to replace the concepts of CPM scheduling. What we're doing is enhancing and adding to that process. So as we go through this, I'm going to touch on 5 primary topics. And really those 5 topics act as a framework for that schedule improvement. So starting off with how to actually, first of all, better define our scope. I think it's very important that we when planning, let's not dive into how we're going to execute the project until we've first of all properly defined what it is we're building. That then leads into both outline planning and more detailed planning. And as part of really both of those processes, I'd like to talk somewhat about a new way of templating, eliminating the need to start from scratch every time we build a new project. And then fifth and finally, human validation. This is something that I think certainly as an industry, from a software vendor perspective, over the last 25 years, we've made fairly impressive strides with regards to helping the planner build a better plan. But I think we've fallen short in enabling those that are actually knowledgeable about the project, the field executioners, the discipline leads. They typically or traditionally haven't had much of an opportunity to buy in and contribute to the plan. Planning has been somewhat sort of a siloed exercise.
And that's where that value comes.
And that's exactly where that comes. And so this somewhat new concept of enabling team members to provide their expert opinion, I think is very, very exciting. So just a quick recap and I guess a very short history lesson. So CPM, or critical path method, is obviously a long tried and trusted technique. It was actually invented back in the mid-1950s by a joint venture including DuPont. It was developed on a UNIVAC computer, which you can see on the right-hand side. That computer has significantly less computing power than most of the phones that we carry around in our pockets today. I think it's actually interesting that 60 years later, the algorithm that we use for critical path method is exactly the same, and it's actually less than 20 lines of code. So the basic premise of taking a project and breaking it down into work, and then breaking the work down into, okay, how long is the work going to take, and what is the order in which that work is going to be executed, they're the inputs into a CPM model. That hasn't changed. And really all CPM does is says, okay, based on the durations of the work and the order in which we're going to do it, these are the dates. That's CPM. It's actually very, very simple. Right? Now the tools have evolved and become more complex, and there's nuances around things like working calendars, so on and so forth. But like I say, the actual basic premise of CPM hasn't significantly or fundamentally, in fact, changed in the last 60 years. Now, I think what's also interesting is that while almost without exception, every major CapEx project uses CPM for forecasting how long a project is going to take, in reality, it's actually, as a science, it's got quite a bad track record. And again, that track record relates back to my earlier comments about, projects finish late and over budget. They don't finish late and over budget. We think they do because our plan was unrealistic in the first place. And one of the main drivers behind that is a CPM schedule. I really think a CPM schedule is more of a best case scenario rather than a most likely. It's best case because the durations and the sequences that we include in our model, they don't take into account potential unknown uncertainties, the downside of what potentially could happen. So even before we start on day one of execution, we've almost set ourselves up for failure because we're working against an absolute best case scenario. I think it's also somewhat odd or ironic that in a CPM scheduling software tool today, when we do a file new, we start with a blank sheet of paper. We start with effectively a blank Gantt chart. Well, that's utterly ridiculous. Yes, in theory, every project is a unique endeavor with a finite start and finish. But if you break down a project, even if it is a very unique type of scope, the more you break down a project, at some point there becomes commonality, whether it's procurement, whether it's early works during construction, whether it's fabrication, whether it's structural steel, so on and so forth. And so not having more guidance from the software in, if you like, templating and having guidance on, well, these are the building blocks that you need to put this plan together. Again, I think we've done the planning industry a disservice from a software vendor perspective in not helping planners through that process. And then third and finally, poor really definition or differentiation rather between what it is we're building and how we're going to build it. And more on that in a couple of minutes. So the topic of today's webinar is really around how what is known as artificial or AI or artificial intelligence or AI can help and improve the planning process. So in very simplistic terms, artificial intelligence is the science behind trying to get a computer to emulate or mimic the way a human being thinks and makes decisions. And AI actually is not it's not a new concept, it's not a new science, it's been around for decades. What has evolved and what is new in really the last 5 years is the speed of computing power and the cheapness of that computing power to the point now where AI can actually sit on our desktop or in the cloud and actually be useful at an achievable and accessible price. And so I believe AI is actually, it's really the next evolutionary step in computing. And why that's so exciting from a CPM and a planning perspective is, for the first time ever now, the computer can actually transform from being a receiving mechanism where the human is just entering information to build a plan, and it's now that concept is rotating where the computer is actually now becoming proactive and starting to guide me. So it's becoming much more of a two-way interaction. So some really exciting technology developments around AI. I think it's important to note, though, that AI is not a magic push a button and generate a schedule. I truly don't believe we will get to that point, or even should get to that point anytime soon. What I do believe is that if we can leverage AI and the computer can make suggestions and guide us through, then obviously that's very valuable. The human, the planner, the scheduler, the cost estimator still has to have ultimate control and ownership over the plan. So there are really two primary schools of thought or approaches to artificial intelligence. The first being what we call neural networks, the second being knowledge-based systems. So neural nets or neural networks are in many ways sort of a black box approach to artificial intelligence. The thinking is that first of all, you have to train a neural network. So if you train it by feeding in enough historical examples, eventually the neural network will pick up on patterns. So a fairly famous neural network example is a few years ago, Google ran an experiment where they fed in literally millions and millions of photographs of cats. And eventually the computer recognized that a four-legged furry thing with a tail and whiskers was a cat rather than the dog. Now, that's very clever, but the problem was the computer couldn't tell the human why the photograph was a cat. It just knew from pattern recognition that it was a cat. It couldn't say, well, it's because, you know, of the attributes. It couldn't say, well, actually, it's not a dog because of such and such. It just knew it was a cat because of the pattern. Now, that's a little bit limiting when it comes to project planning, because let's say we can get the computer to make a suggestion on a duration for earthworks. If it just comes up and says, hey, Carolyn, 60 days for early works and earthworks, and you say, well, that's great, but before I plug that into my schedule, I need to know why. If the computer can't tell you why, that's a very hard to defend piece of information to put into your plan. So that's why we've adopted more of a knowledge-based system. So a knowledge-based system comprises several components, as the graphic suggests on the right-hand side. So first of all, we have what we call a knowledge library. So knowledge library is where we store historical information, and that's historical information can include prior schedules. So if we previously developed a plan in, say, Primavera or Microsoft Project, those historical schedules and plans can all reside in the knowledge library. Additionally, a knowledge library should be able to store what we call unstructured data as well. So unlike a database where you have a defined set of tables and fields, a knowledge library is much more freeform. So the ability to store things like risks and opportunities from, say, a risk register or a Word document included in the knowledge library is very important as well. So that's the storage of knowledge. And then moving from left to right, really the brains, if you like, in a knowledge-based system is what we call an inference engine. So what an inference engine does is when the human or the planner asks for a suggestion, the inference engine needs to understand context. And understanding context, again, you know, am I in engineering, procurement, construction, closeout, commissioning, and also the type of project, the location of the project, the complexity, the quantities, all of those variables that drive the duration, the context. It then uses those variables to understand context, and it goes off and it interrogates the knowledge library. And what it does then, it returns suggestions. Okay. Now, what we've done in the InEight Basis Suite is, rather than being so bold as to say, well, we're going to go off and the computer is going to just come back with the best suggestion and plug that in. We've taken that a step further, and in some ways it's more of a humble approach, because what Basis does is it actually comes back with multiple suggestions, and to help guide you as the planner make a decision as to which of those suggestions you adopt in your plan, it comes back with a confidence level as to how certain it is that it's given you the right suggestions, if that makes sense. Mm-hmm. So it's somewhat analogous to doing a web search. You get your 10 returns, and each of those returns carries a percentage fit or hit, and then you make the decision as to which one of those you go with. So that's the kind of the technical approach that we're using in taking CPM scheduling to the next step. So the 5 steps that I mentioned, what I'd like to do is walk you through these at a fairly fast pace, and then we'll actually dive into the product, and I'll show you how this actually works in reality.
Okay.
So first and foremost, generating what we call a WBS, or work breakdown structure. So I alluded to this earlier, but in a traditional scheduling tool, we start with a blank sheet of paper and we start building out a hierarchy of stuff. And scheduling tools have done a really terrible job of encouraging, or I believe we should even force or enforce, the differentiation between scope and work. So scope is, what is it we're building? We're building a garden shed. Okay, the garden shed has foundations, it has walls, it has a roof. Okay, well, that's very different to the work. The work is, we need to get a shovel and dig the foundation. We need to put up a frame for the walls. We need to do sheetrock. We need to do weatherproofing. And then for roofing, we need to do things like waterproofing. So the aim is the action, that's the work. Well, that's very different from the scope. So what we're suggesting is, as a precursor to defining the work, we should do a better job of defining the scope. If we do that, then when we come along and identify the work, the activities, the logic links, all of the stuff that builds up the CPM schedule, we can then do an analysis to make sure that, do we have enough definition of work against each of the deliverables that we're being asked to deliver in our project. So it's a much more systematic approach to making sure that we've encapsulated all of the work that's needed to execute, to deliver our deliverables, if that makes sense. So to help with that, what we've done, we've introduced a concept where, when upon project creation, again, rather than starting from scratch, the computer will actually ask the planner questions that then leads to the generation of that WBS, or work breakdown structure. So 2 benefits. One, we're not starting with a blank sheet of paper because we have the structure already built. And secondly, we get to define the level at which we're about to build out our project. So what I mean by that is, in our knowledge library, let's say we have historical Primavera schedules, and they go down to, I'm going to be extreme, they go down to, say, maybe 12 levels deep in the work breakdown structure. Well, for my project, I may not need or want to go down to that level of detail. Well, what I can do in Basis is I can say, well, I'd like to inherit from that incredibly detailed hierarchical breakdown, but I want to roll up, maybe only up to level 3 or 4. So I still get to include all of the different areas of scope. I'm getting the benefit of templating and pulling from the knowledge library, but I'm not getting so bogged down that I've got 5,000 WBS elements that is just too much detail for what I'm building. So the ability to automatically roll up and inherit from a prior WBS is really powerful. The other benefit is, again, if I'm pulling from a WBS template from a previous project, the previous project, if we're doing, for example, a vertical building, the vertical building that I'm pulling from may have been a 50-story building, or the project I'm working on may be a 20-story building. Well, it's not fair for me to inherit the durations from the 50-story building because my scope of work is much less, even though it's the same type of project. So the ability for that WBS template to be calibrated accordingly during the project creation process is something that's really important and quite magical to a planner, because again, they get the benefit of the structure of the WBS, but it's been calibrated down to the size of their project. Mm-hmm. It was a little bit technical, but hopefully some of that resonated. All right, top-down timeline development. So for those of you that have gone through the likes of PMI or AACE training, you'll know that theory states that there's typically 5 phases in a project, from concept, planning, execution, monitoring, and closeout. And then the second of those 5 phases obviously focuses around planning. Now, I think this is somewhat confusing and actually to the point where it's actually not correct, because I would suggest and argue that during any of those 5 phases, let's start with concept, you're actually doing planning. So in my very early concept and concept select phase, when I'm deciding on alternate scenarios for my project, what am I doing? I'm planning. I'm trying to figure out which of those scenarios to go with. Yes, of course, I'm doing planning and detailed planning. When I get to execution, what am I doing on a daily basis? I'm consistently replanning as things change out in the field, out on the construction site. So planning is actually done at all of those phases. So the ability now to plan prior to the planning phase in what we call pre-planning is a huge opportunity, because what it allows us to do is it allows us to sketch out or define what we call high-level timelines. So these can be as simple as just different phases. We're not getting into the complexities of having to define logic and all the CPM stuff. This is purely outlining our best estimate as to how long and how much money each of the high-level entities are going to take in our project. The real benefit then is when we get to our detailed planning in the planning, execution, monitoring, and closeout phases, we can hang our detailed plan against those high-level timelines, and then understanding the alignment or misalignment of those two, it tells us whether or not we're executing as per our plan or not. So it gives us much more insight into true performance or true execution performance. Previously, we had nothing to compare to. So again, a big benefit in more continued planning all the way throughout the project lifecycle. All right, number 3, rapid templating and what we call subnetting. So again, for those of you that are very close to CPM scheduling, you'll be more familiar with the concept of subnetting. So a subnet is, in non-technical terms, it's a chunk, it's a nugget of your overarching schedule. And again, historically in scheduling tools, it's been really difficult to go to a previous project and just do a copy-paste and pull in those subnets and build up sort of your tapestry by doing that copy pasting. And the reason is primarily through logic links. So you can't just take a subnet and extract it from the rest of the schedule and plonk it into your plan without having to first of all cut the logic, and then when you do the paste, having to resew the logic back. Okay, so we've come up with an incredibly effective technique where, when doing that templating and doing the copying of those subnets or chunks from a previous project, the software is smart enough to remember the cuts. Now, why is that important? It's important because when we do the plonk back, the paste, right? Instead of just plonking it into our schedule and it just sitting there in the ether, Basis understands that, oh, there are links that we cut during the copy paste, and it will actually make suggestions as to how to sew them back. Well, that's pretty amazing, because if you can do that, then it's very, very fast to do the templating, but also you're ensuring that the relinking of stuff is being upheld in your plan. So
not just a plonk.
Not just a plonk, exactly. So this is again a huge step in speeding up the development of planning through the use of templating. But again, ultimately, I think the biggest benefit is the resultant schedule or plan that you end up with is more realistic. The screen on the right-hand side is an example of subnetting, and just to touch on the color coding there, another concept that we've introduced into Basis in the last 3 months is when I'm doing my copy pasting and I'm doing my subnetting. Prior to Basis, there was no way of knowing that the subnets that I'm pasting into my schedule are sitting in the right phase of the project. So let's take an example where we've got some concrete work going on, we've got some steel work, and then we've got some room fit out towards the end. The white, the orange, and the green rectangles effectively. Well, what BASIS is telling me here is I've done a subnet insert around the steel scope of work in the center there, and it's correctly brought in the activities and the logic links and all that good stuff. But what BASIS is doing, because it understands context, it's saying, hey, Dan, typically, in order to finish closeout on time, when you do your steel work actually is executed earlier on in the project. In fact, it's executed where that orange-pink rectangle is. So it's telling me that, yes, I've got the correct scope of work in my project for steel, but it's happening at the wrong point in time. Well, that's amazing. I mean, for a computer to be able to help give me a warning sign that, okay, I've got the right activities, but I've got them at the wrong period of time, that's a huge step forward in improving the realism of a CPM schedule.
And a chance to fix it.
And the ability to fix it, yes. Yep. All right, number 4, establishing task durations using productivity rates. So this one kind of makes me laugh. So again, in a traditional scheduling tool, you'll type in a activity description, and then when it comes to duration, which is the main attribute of an activity, what do? You just type in on your numeric keypad, you just type in a duration. There's no requirement for defending where that number came from. I can just go in and type 30 days for my duration. There's no justification, there's no backup, there's no basis of estimate as to where that 30 days came from. Well, in BASIS, we've taken that to really to the next level, whereby instead of just arbitrarily typing durations in, we take a step back and say, well, if you can tell the computer the scope of work, what is it we're working on? How many units is it? So maybe it's, in the example on the screen here, we're doing a concrete pour, and the computer says, okay, well, how many cubic yards? Okay, 100 cubic yards of concrete. Okay, well, I know historically that it takes 2 hours per cubic yard to do a concrete pour. Therefore, based on 3 crews, it will take 9 days based on the working hours per day. So instead of me just typing in 30 days and hoping that I'm correct, by me simply telling the computer the scope, it's 100 cubic yards of concrete, the computer's gone off, looked at historical productivity rates, and come back with a duration. Well, that's very, very defendable as an estimate. It's also more realistic because it's based on previous performances on projects that have been involved with concrete pours. So it's a very different way to creating durations in a schedule, but it's a much more, again, defendable and true way of developing those durations. All right, and 5th and finally, so tying it all together with team member validation. So I've talked a lot about the wonders and the magic and the mathematics behind what we call artificial intelligence. So I think that's important because it calibrates your plan, right? But what it really doesn't ultimately do is it doesn't really validate. And I think the validate comes from the human side. So as a combined partnership between the AI engine and me, the best planner on earth, I can come up with what I think is a great plan. But unless I've had it critiqued and bought into by team members, stakeholders, field executioners, I still may have got it wrong, right? So the team member validation, we actually call it HI, or human intelligence. And what this is an opportunity for me, the planner, to canvas multiple team members on different sections of the plan. And instead of those team members being presented with a complicated Gantt chart, and them having to understand how CPM works, all they get presented with is a very simple scorecard. And you can see an example of that scorecard on the right-hand side. And the philosophy behind this, it's almost like voting. So on the right-hand side, you have your colored columns there. You've got -50, -25, 10, okay, 10, 25, 50. So this is our degree of buy-in. If we think certain activities require significantly more time, then we push our voting towards the orange on the right-hand side. If we're very, very comfortable to the point where we think, for example, Royston Crossing here actually needs less time than I have in the plan, then we steer or veer the voting to the left. Okay, so it's like very easy sliders. And what's really, really cool about this is behind the scenes, the computer then takes all of those opinions from multiple team members, and the opinions might be completely different, right? So Sasha, you might have a completely different opinion on the Royston crossing duration than the rest of the team. That's okay, because what the computer does is it comes up with a consensus view of what should be put back into the plan, and then I, the planner, have the opportunity to say, actually, yes, I want to go with a consensus, or no, I want to continue with my input for whatever reason. It's consensus-based planning rather than just me acting in a silo. Okay, so that's the theory side of things. So that was the 5 steps that I alluded to in the introduction. So assuming we are still okay for time.
Yes, we are.
Do we have maybe 10-15 minutes to do a little product walkthrough and see how this really works?
Yeah, do that. And I'll encourage the audience as well to send in any questions that they have while you're doing the demo.
All right. Okay, so I'm going to play the role of a project planner. So I've logged into Basis. Basis is a web-based or cloud application. So there's nothing to install on either my laptop or my tablet. I can see here a list of existing projects that I'm either the owner of or I am a contributor to. Behind the scenes, the knowledge library, remember earlier we talked about this is where that non-structured data can reside. So this can be a series of prior schedules from different scheduling tools. It can be previous risks from risk registers. It can also be, and I didn't mention this in the introduction, the knowledge library can actually be as simple as a list of standard productivity rates pertaining both to time and cost. So if you are perhaps a smaller organization, maybe an SMB organization that doesn't have 20 years of historical project history behind you, you can actually benefit from Basis by having as little as a single Excel spreadsheet with just standard productivity work rates in it. The AI engine, the inference engine, works in exactly the same way, pulling from these productivity rates rather than going off and looking at as-built schedules from our previous projects. So this is where all of the knowledge resides. So let's now take a look at how we leverage that knowledge during the building process of a project. So I'm going to go ahead and create a new project. And I'm simply going to give the project an estimated duration of, say, 2 years. And again, my best estimate as to how much the project costs, I'm going to say I'm estimating $200 million for this project. Now, the next step in project creation is where we start to give the computer some context. So, for example, I'm going to say this is a commercial construction project, and I'm building this in North America. So these attributes are the starting point for telling the computer, I'm now starting to tease the computer as to the type of project, the size of the project, the cost of the project, so on and so forth. Okay. So third and finally, for project creation, I mentioned that the first of those 5 steps, we talked about WBS creation. So again, because the computer understands that I'm about to plan out a commercial building project, it's come back with a standard WBS structure for a commercial building project. Well, that's kind of cool. But what I can say is, well, actually, for where I'm at right now in the planning process, I'm really at the concept phase. I don't need all of these detailed levels. So I can roll up my WBS structure to whatever level I choose and use that as the starting point. Now, while this might look quite simple, behind the scenes, it's actually quite remarkable because it's doing a schedule roll-up. It's taking the very detailed structure of a CPM schedule and rolling up to summary levels. So let's go ahead and assume that summary is the starting point for our project. So I've kind of made this hard on myself on purpose just to show you how easy it is to build out a more detailed schedule. I've literally got 1, 2, 3, 4, 5 WBSs here from early design, front-end engineering design, procurement, construction, summary of the project, and closeout. Now, each of these summaries actually contains a lot of information. So obviously, Basis has gone off and pulled the standard durations for feed, procurement, construction from the knowledge library. So these are the durations that it typically takes to execute engineering, procurement, so on and so forth. And secondly, it's time phased them again against where typically those different phases of a project would be executed. Thirdly, it's even brought in historical cost information. So again, traditionally feed engineering has cost us $400,000, procurement activities, things like long lead items, 4.3 million, so on and so forth. Well, this is actually very useful because in a minute, what I'm going to do is I'm going to start detailing out the schedule. I'm going to put my own durations and costs and phasing. Well, if I have my interpretation as to how long and how much it costs to build the project, and the computer is saying, well, typically it costs and takes this much, well, what do I get? I get benchmarking for free because I can use the computer then as a yardstick to make sure that I'm staying within the realms of how much, how long, and in which order should we execute the work. Okay. So there are really three levels of smartness, I would say, when building a plan in BASIS. So if I really want to make life hard for myself, I can manually add things like planning packages and activities. So this isn't really too different to good old traditional scheduling in a scheduling tool. If I want to be a little bit smarter, though, I could say, okay, well, typically during my feed engineering stage of my project, I have varying degrees of clarification, and they all happen in sequence. So what I'm saying here is I'd like to break out my feed scope into 4 sequential activities. Well, boom, there's my 4 activities. They're all in logical sequence. Well, to do that in a traditional scheduling tool would take, I'd have to create an activity, create another one, create another one, create another one, add a logic link, add a logic link, add a logic link, move them around. It's a really treacherous, tedious, expensive process. So these accelerators are very, very useful. Now, I still get to manipulate and manually edit the durations in the sequence, but what's very nice here is, if I go back to the original duration here, you see the little green mark indicator at the top? This is like a threshold. It's saying, well, typically feed engineering falls within this boundary. Now, if I were to extend one of the durations within my detailed schedule, that will actually, extend the duration, that will actually turn to orange, and that orange is indicating to me that now my overall feed duration is taking longer than we would typically see on this type of project. Well, that's kind of cool, right? Because again, it's benchmarking.
Very smart.
So the next level of smartness, let's go down to procurement. So procurement, 205 days. So as a less experienced planner, I am not very savvy with regards to procurement and construction activities. So I now want the computer to give me some guidance. So on the right-hand side, you'll see here we have what we call basis suggestions. Okay, so these basis suggestions, we've got different procurement scopes of work coming in from different historical projects. These are suggestions that the inference engine, the AI engine in BASIS, is making. So I can look at these and I can say, okay, commercial building procurement. Let me take a look at this, and let me understand what is typically in this scope. So typically, oh yeah, submittals and approvals. That makes sense. And we've got structural steel, so on and so forth. So we do our procurement process, and then we do fabricate and delivery. So we again, we've got fab and delivery for our different entities here. So if I'm comfortable with these, then what I can do is I can preview this. And what it does is it goes off and it pulls the activities, the logic links, and everything from the knowledge library. Look at that. It's automatically generated my detailed plan for procurement. Well, I knew very little about procurement, and now I've taken advantage of the historical procurement subnets that we had in our knowledge library. I'm doing this templating approach without having necessarily to have that inherent knowledge around procurement. Does that make sense? Mm-hmm. Now, this little, well, there's a couple of markers here. This little yellow marker here, what this is telling me is typically on procurement, there is risk pertaining to competing work in the fabrication yard. So not only is BASIS telling me these are the activities that we need for procurement, it's even smart enough to tell me common risks and issues that occur during the procurement scope. So that's, again, very useful to me because I can apply that risk to my project. I can give it a probability and maybe a 30-day potential impact to my project. That now gets embedded in the plan and becomes part of my project risk register. So again, I didn't have to have this inherent knowledge around what it takes to procure stuff on a commercial building, the tool is telling me both the activities, but also common risks associated with that kind of work. So that's kind of cool. And then secondly, this little exclamation mark, this is actually telling me, remember earlier we talked about when you pull in a subnet, you have to cut the links and then you have to resew them. So this is reminding me that I've done a cut, but I haven't yet sewed the link back. So what I would do is I would say, okay, well, I typically wouldn't start procuring until I'm done with my early feed engineering. So I'm going to create a logic link between the two. So great, now the error's gone away. But boom, now we've got an issue because it's logically linked, right? It's pushed my procurement scope out to the right. And what it's telling me is the orange box here is telling me, well, actually, typically procurement should happen in early to mid 2019. Your procurement's not happening until early 2020. It's too late in the sequence of work for this type of project. So what I can do is I can look at that and go, you know what, you're right. And in this case, I can either accelerate some of my engineering work, or perhaps more realistically, I would say, well, I'm going to start some of my early submittals before I've actually finished some of my feed scope. So again, for those of you that are CPM planners, different ways of modeling that, but you can offset the logic. I put in a negative lag there. It's brought the work back, and it's now falling within the typical start and finish period for procurement.
Well, that was 10 minutes, but we're still getting questions. So
we're getting questions.
You can keep demoing.
Do you want to hit me with the questions, or should we keep going?
I'm not sure whether you prefer to be interrupted.
It depends how hard the questions are.
Well, we got a few that are very similar. So
go for it. Yeah.
Can you use external estimating data from databases like RS Means? And then we've got a few flavors on that.
So yes, in the knowledge library, you can either create knowledge directly in Basis, or you can link to or import from external data sources for both cost and schedule data, yes.
And a couple of the questions were about how this is linked to your estimating database. And for example, can you pull in information that's specific to a location? So two questions in the question there. So the first part of the question was around integrating with estimating tools, data, or estimating tools. So yeah, the same thing applies in the knowledge library. You can import or link to external data, including estimating tools. Now the second part of the question is actually a very exciting part of the project. So I'm going to completely mess up my demo here and go into the knowledge library. See, we should have done questions at the end. Well,
no, this is good. This is good stuff. So pertaining to location, we've got the concept of what we call knowledge tags. So think of knowledge tags as attributes. So an attribute can be geographical location. It could be the customer that we're working for. It can be the business unit that is going to execute this project. And what it does is, if I go down to location, I've got like Arctic, Australia, China, Europe, North America, South America, etc. here. You as an organization, you get to define the different locations, but more importantly, you can actually then tag those locations with what we call a normalization factor. So let's say, for example, you've got a project in your knowledge library and it was a fabrication of a FPSO rig, and it was fabricated in South Korea. And you know that the typically fabrication in South Korea is 10% more efficient than fabrication in the Gulf of Mexico in the US. By putting in that factor, what it does is at runtime, when I'm building my project and Basis is giving me my suggestions, as it was previously, if you remember, we were building out our procurement scope. When it gives suggestions, if the suggestion comes from a project that was executed in South Korea, remember at the beginning, I told the computer we're building the project in North America. So 100-day duration in South Korea would actually be 110 days if we were to do it in North America because of the differences in efficiency. Mm-hmm. So the computer's smart enough to normalize what it throws over the fence in its suggestions. So hopefully that answered that question.
I think that will.
All right.
So let's take in another direction, and you might talk about this too, whether there's a special plugin for Jira or MS Project.
There is for Project, there is not currently for Jira.
Mm-hmm. Think which direction they're taking it.
Okay, let's keep going with the demo, otherwise my presentation on finishing stuff on time is going to be ironically overtime. So let's close out on construction. Again, I could manually build out my construction scope and activities, etc., or I could take advantage of the suggestions that Basis is giving me here on the right-hand side. So these are historical projects, again, pertaining to this scope of work. And let's go ahead and take a look at this. So foundational work, structural work, so on and so forth. This looks good, except my project is only a 2-story building, so I don't need the 3rd floor scope to be included. So that's pretty cool. I'm pulling in an analogous project, but now changing the scope. I'm going to go ahead and take a look. Okay, nice degree of detail here. That's looking pretty good. Yes, I want to commit that to my plan. And of course, again, I've got my logic link error here telling me I need to go up and tie that logic link, the sewing that we looked at earlier. So I guess in the interest of time, we're at the stage right now where we created our high-level plan, we did our timelines, our time phasing. We can see that our procurement scope it's on the edge of being okay with regards to when in the project lifecycle it falls. We've detailed out our construction scope. At this point, I'm pretty comfortable with my plan. And so what I can then do is say, okay, well, I want to establish this as a baseline, and I now want to invite some team members to review the schedule. Okay, so I may say to the likes of you guys, well, okay, I want you to review and go through that scorecarding process. So the scorecarding process, I could say, okay, for construction, I would like to invite some team members to review. So again, in the interest of time, we'll just add myself as a reviewer, and then the reviewers, what they see, as we mentioned in the PowerPoint, is the scorecard view. So the idea is that because we've just asked you guys to review construction, you only get to see construction in the scorecard, and you may look at the entire scope and duration and go, yes, I'm okay with construction as a whole. The computer here is telling me, the planner, that I actually, this is user error, so please review. What it's doing here is it's starting the review cycle. I actually tried to do my review before the review cycle had started. So let's go back into our markup view, and now the green light is green, which is good. So again, we can start to review the construction scope. So yes, I'm okay with the whole of construction, but our grade and support beams here, 20 days, that's very, very aggressive. We need at least 25% more time. And what's really, really cool about this is, because I'm asking for more time on grade and support beams, this is the precursor to everything else in that sequence of work. I, as the team member, get to see the knock-on effect of me asking for more time. You see the little lightly shaded bars to the left of the schedule. Taking that to the extreme, if I ask for 50% more time, look, we get to see the increased knock-on effect. And I could do the same for any of the activities in the schedule. So what's happening here is I, as a team member, am giving my feedback. To give you an example of a project that's already got a review process underway with multiple team members, here's an example where we invited Paul and Alan and Ben and Christy to all give their feedback. And again, as the planner, what I can see in real time is how much pushback and how much buy-in each of those team members are giving me to the plan. And when I'm ready, I can then do what we call a review. And within the review view, again, if I drill down to construction, I can see in the Gantt chart here, you see where it says pending, 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 pending? These pending elements are telling me that there are one or more team members that have given input and opinion, and it's up to me now to review that. So I can say, okay, well, for grade and support, I said 29 days, Paul said 23, Christy said 20. So I get a choice here. I can take the general consensus and commit that to my plan, or I can say, you know what, Paul is the expert on grading and support. I just want his opinion to make it back into my plan. And again, by doing so, not only does it get sent back and embedded in the schedule, the knock-on effect gets visualized as well. So on a per activity basis, I can review each of the team members' inputs and decide how much of that expertise makes it into the plan. in terms of kind of insight and analytics, one thing that's very useful is this little mobile phone or cell phone tower icon here in the grid. So what this is showing me is if there are a high number of bars, this is telling me that there is a high degree of consensus between team members. So if I go to, say, decking, decking 52, 33, 38, 41, it's a fairly high degree of consensus. If I go to steel deliveries, then there's a much broader range. Let's take one with an even broader range of durations here. So like final reinforcing, look, we go anywhere from 18 days to 65 days. That's a massive range. So that's a very low degree of consensus. So again, as a team, we really want to pinpoint and focus on it's okay when people agree on stuff. That normally means a high degree of confidence. It's the elements that have a low degree of consensus are the ones that we want to focus on. So this review process historically would involve spending 2 days in a conference room with the project team doing a schedule review workshop. Very tedious, very expensive. The massive benefit here is each of those contributors can do this in the comfort and luxury of their own time in their own office. And I, as the planner, I get to see that input coming in real time and can update the schedule accordingly. Pretty cool stuff, huh? So I know there was a question about the thumbs up, thumbs down on the right-hand side in the Gantt chart. So what this is it's an indication to me as to how aligned is the opinion of the team to the plan that we put together at the beginning. Remember, the plan we put together at the beginning was largely influenced and guided by the AI and the computer piece. Well, what this is saying is for this particular project, overall, the team member opinion is actually quite different. This is a 0 to 10 scale. So we call it the Realism Index. So it's a benchmarking metric as to the team's opinion versus the plan that I put together as the planner when pulling in from the AI engine. And again, it breaks it down throughout the scope of the project. So if we go to, let's go to, for example, floor one is great, 10. That means the team are exactly in alignment with what I put together in my plan. Whereas if we go to our foundation scope is massively different. In fact, it gets 0 out of 10. So again, what we're trying to strive towards is as much realism and achievability as possible, and that's what that index is used for. So at this point, I built my plan. I've asked for team member feedback and contributions, and then we've gone through this review process where on either a per activity basis or even I can do a global edit. So for construction as a whole, I can say I want to take everybody's contribution and embed it into the plan. This is now my updated schedule. And at this point, I can either continue planning in Basis, or I can choose to export and take my updated plan and push it to the scheduling tool of my choice, whether it's Primavera, Microsoft Projects, so on and so forth. So, we walked through that in probably 20, 25 minutes. The speed and ease at which I can generate a plan is amazing. But again, I think more importantly, the fact that I can defend my schedule and what I'm building based on historical information and also then validating it from my team members is something that we've never been able to do before.
So you've got someone who's asking about how you use this and apply it for a project that's already in execution.
Okay, so a project that is already in execution, as I mentioned earlier, planning isn't just done during the planning phase, it's done during execution. So if we have an in-progress schedule, the same applies. You could take that in-progress schedule, if you're tracking it in say, Primavera, link it or load it into Basis, and then you can use Basis then for two things. You can use it for getting team member validation as to how much work we have left. You can also use it for statusing, and you can also use it for benchmarking the remaining work as well. So it's equally applicable for in-progress schedules as it is for planned schedules. The other benefit of both the planning phase and the execution phase is, remember we had all those team members giving differing opinions. Well, those differing opinions effectively give us a range of durations. Well, for those of you that do risk analysis for schedules, you'll know that the whole concept of modeling risk is you plug in ranges of durations rather than single values and you run a Monte Carlo simulation. Well, because we're generating ranges in Basis from multiple team members, you get your inputs into your risk model for free. So that actually, again, negates the need for doing things like risk workshops. Basis will generate the model needed to run the risk analysis.
I think that's a helpful answer. And we have a couple of people looking at this before you wrap up. Last question. There are a few people looking at this, not unlike the JIRA question, from a software development perspective. So perhaps you'd like to comment on the usability of the tool for that.
So software development is an interesting beast because in many ways it goes against the grain of CPM. So CPM is very powerful and applicable when stuff is in sequence. You have to build the foundation before you build the wall, before you build the roof. In software development, you can arguably, although there's the concept of the mythical man month, you can arguably throw a whole bunch of resources on day one in software development, and in theory, you can accelerate your project. There's less physical dependencies in software development. I think where Basis is very useful in software development is gaining consensus on how long we think things are going to take. Now, once you've established the buy-in into those durations, whether you then continue to plan your software development in a CPM tool like Basis or P6 or Project, or throw it over the fence into a JIRA or some other task-based planning tool, I think is neither here nor there. It's the getting the buy-in into those durations that I think is useful.
Okay, we'll let you wrap up.
All right. Well, this is the last slide in the deck, and I get, from a big picture perspective, again, it's important to understand we're not trying to replace CPM. CPM has been around for 60 years. It's going to be around for another 60 years. I think what we're doing is, instead of inventing something new, we are innovating and making better the science of CPM. We're making the inputs into CPM scheduling faster and more realistic. CPM is just mathematics. It's going to spit out whatever answer. It's going to spit out an answer based on the inputs. The problem isn't the algorithm and the mathematics. It's getting the inputs right. And what we're doing at Basis with AI and the knowledge library and the inference engine is ensuring that the inputs that go into a schedule are more realistic. And if you have more realistic inputs, then by design, your plan is going to be more realistic. And for me, what's so exciting about this product is we're not just looking at the scope of work or can we get the durations right. The software is smart enough today to even understand things like sequence and whether we've got the right work happening in the right phase. Remember, we did the color coding with the phasing. And then, I think sort of tying it all together with the human intelligence part, again, there is no magic button in Basis to spit out a schedule. The AI it's augmented intelligence, it's guiding, it's suggesting, it's helping the planner, and then we're getting confirmation from the team through the HI. So that's where we're at with the product today. This is actually the first of 6 webinars that we're doing over the next few months. I know the next webinar I'll be focusing more on benchmarking, but also this is actually, in terms of the overarching InEight series of webinars, the Basis webinar is actually one of 3 tracks that we're running. So today I've obviously focused not just very heavily, entirely, I think, on scheduling. The next webinar on Monday, February the 4th, jumps over to our document management solution. And I guess we're into 5s because that one talks about the 5 foundational must-haves for document management success. So I know very little about that, but I'll sure to be dialing in and learning all about it. So I guess in the meantime, if any of you have any additional questions or would like a more detailed dive into Basis and how we're leveraging AI, then as per the slide, you can contact us at sales@inneight.com, or the marketing folks at InEight aren't going to like this, but you can just email me directly as well. Daniel.patterson@inneight.com is fine too.
And then it gets your own personal demo.
Exactly. So So I think with that, let's go ahead and wrap up. I really appreciate you all spending an hour of your life today listening to me, sharing what I passionately believe in with regards to improving CPM and the science of scheduling, and look forward to chatting with you all in the coming weeks. So thank you.
Thank you, Dan. This concludes our talk today on Harness the Power of AI for Faster, Accurate Plans. Thank you and goodbye.